Hey, how you doing, guys? It's Ilya Belly here. I do coding stuff on YouTube. Check the description for all my information. I do all LeetCode problems. Make sure you subscribe to the channel. Give me a big thumbs up to support it. And this is called Find Peak Element. A peak element is an element that is greater than its neighbors, given an input array nums, where nums at I doesn't equal to nums at I plus 1. Find the peak element and return its index. The array may contain multiple peaks. In that case, return the index to any one of the peaks is fine. You may imagine that nums minus 1 equals to nums n equals to minus infinity. As you can see, like here we just return 2 because like 3 is greater than 2 and greater is 1. And here we can return 1, right, or just 5, because like here 2 is greater than 1 and is greater than this one, right, and 6 is greater than 5 and greater than 4. Well, that's pretty obvious that we can solve this problem using binary search. We just do like binary search. That's it. Let's start. So first, as you know, guys, you need to set up two variables. Int left equals to 0 and right equals to nums dot length minus 1, and you create a while loop while left is less than right. You check if left plus 1 equals to right. That means that, suppose we like take this example, like when we got two elements like this one, plus 1, like 0, 1, 2, 2 plus 1 will be 3, 3 equals to 3, so we just return the greatest value, the bigger one. So if nums at left is greater than nums at right, we return left pointer, and otherwise we return the right pointer. Then we set up middle. To calculate the middle pointer, you need to say left minus left plus right minus left divided by 2 to prevent an integer overflow. That's how we calculate that in Java, right? And then we check if nums at middle is greater than nums at middle minus 1, and also nums at middle is greater than nums at middle plus 1, we return the middle. Else if it's not, then we check if nums at middle is greater than, again, middle minus 1, and nums at middle is smaller than, is less than nums at middle plus 1. In this case, we set up left to middle plus 1, and else we set up right to middle minus 1. And finally, we just return the very last pointer. I mean, like, you return the left pointer because we are moving kind of like, you know, the rightest pointer means that there is a peak. So we just return left. Let's run this code first. There we go, accept it. Success, great. So basically we got a couple of cases here. Suppose like we got like middle, right? And if like nums at middle minus 1 is greater than nums at middle, and nums middle is less than nums at middle plus 1, that means that there are peaks on both sides, right? To your left and to your right. This is the smallest value here. So yeah, in the case when like, let's copy and paste that to say something like, you know, if nums minus 1 is greater than nums at middle, and nums at middle is, or just, you know, let's say it's middle, like middle minus 1 is less than nums of middle, and nums at middle is less than nums at middle plus 1. Then there is here both sides have a peak, right? Both sides have peaks. Here that means that there is a peak on the right hand side, right? There is a peak on the right hand side, and if middle minus 1 is greater than nums at middle, and nums at middle is greater than nums at middle plus 1, there is a peak on the left hand side. And if in the case when nums at middle minus 1 is smaller than nums at middle, and nums at middle is greater than nums at middle plus 1, that means that there is a peak, like we just return middle because nums at middle is a pig. These are the cases here. Thank you guys for watching. Leave your comments below. I want to know what you think. Subscribe to the channel, give me a big thumbs up, follow me on social medias. I do all LeetCode problems. Yeah, thank you. I wish you all the best. Bye.